Welcome to statistic learning session. Today we'll be continuing the asymptotic test. In last session, we established an expression, asymptotic expression, where we had this expression that was equal to, let me just make this work. We have this expression which was equal to x x hat n y hat m delta d minus delta c divided by delta d square n plus delta d c square m. This was an asymptotic expression we established last time. Now we'll take one step further and see how we can use this asymptotic statement to create a test. The test statistics, this Tn is a test statistics. Tn is a Tn is a test statistics that we have, and in this expression what we see is there's a sigma delta d and delta c. These are unknown at the moment, but under null hypothesis delta c and delta c minus delta d is equal to 0. If we go above here, we can see that delta c is equal to delta c and it is equal to 0. Therefore the tn becomes, what is the tn becomes? Tn becomes xn minus ym hat delta d square delta n delta c square delta m, and it is greater than c. It is some threshold value. So what is c here? Since this is a one-sided test, c is q. C is q alpha. Q and q alpha is 1 minus alpha quantile of n 0 comma 1. Can you tell me it is one-sided or two-sided test? It is one-sided test, and can you tell me is it one sample or two sample test? It is two sample test because we had one we had a we divided a population into two sample. One was a control and other was a benchmark. So this is two sample test. Now, next we'll do some example. In this example, we have two population. One is control and one is benchmark. The control population is M, which is 50, and test population is N, which is 70. 70 are people for which we are giving drugs, and M is the number of people for which we are giving placebo. The mean, sample mean of the sample mean of placebo, the sample mean of drug is 156.4 deciliter, while sample mean of placebo is 132.7 deciliter. Now, there's a variance in this sample mean, and there's a variance in the sample for drug, and there's a variance sample for control. The variance in the sample is greater for drug than for control. That is around 5,194, and while for control is 3,867. Now, let's go ahead and plug in the values for our test statistics. That is Tn is equal to 154, 154.6 and 132, and delta square is 15194 divided by 70 and divided by 50, and is 1.54. That's what we get. Now let's build the test where sigma is Tn greater than Q alpha. Tn is not absolute, not absolute for one-sided. Then Q alpha becomes Q 5%. Therefore, our test statistics equal to Tn is greater than 1.645. Hence, this is false. 0. False. Therefore, we cannot disqualify or reject the null hypothesis in this case. Therefore, it seems that drug is no better than placebo. Now, at 5% level. Now, let's compute the p-value. How do you compute the p-value? P-value is, what is p-value? P-value is a minimum alpha at which we can still reject null hypothesis. Therefore, the formula for p-value will be equal to probability of Tn greater than evaluated Tn equal to 0.5%. Now let's calculate this. Probability of Tn is greater than 1.57. What is 1.57 in terms of alpha? What would it be equal to? Can you tell me? Let me check. For this one, it is equal to 0.0582. What he's saying is that if this is a normal curve, probability of Tn, which is Tn, greater than 1.57 is 0.0582. That is 5.8%. Therefore, what it says is that we can only reject null hypothesis at alpha percentage is greater than 5.8 or above. If it is 5.8 and less, that is 1, 2, 5, we cannot reject null hypothesis. That was saying. In the end, let me quickly summarize what we learned today. We learned about asymptotic tests and clinical trials. We calculated the expression for test, where we created a test under null hypothesis by substituting alpha delta d and minus delta c equal to 0, because that's what it is under null hypothesis. Then we calculated a test statistics for our hypothesis testing. Then we went ahead and took an example where we were given a value of n, m, sample average for xn and sample average for yn, delta d sample variance for control, and sample variance for test group. In this way, we will compute that we cannot reject the null hypothesis based upon this data provided. Then we went ahead and took one step further and calculated the p-value for our test, which provided 5.8%. That tells us that we cannot reject anything below 5.8%. We can only reject at 5.8% or above. That's all for today. I will see you next learning session. Thank you so much.